Hi folks, I'm Kyle Lamb. I'm out on the range here with Jerry Speech. He's one of the head engineers over there at Kinshot, also the vice president. Yes. And we want to talk a little bit about the hydraulic buffers that he designed. Okay, so I think you know in the past I was not a fan of hydraulic buffers because of some of the failures. And one of the things you told me earlier that I thought was really interesting, you said that you went to town with every failure that the other companies on the market have had.
That's correct.
And you fixed all those failures with this product.
That's correct.
So tell me what some of the failures were.
Well, some of the things that they have done was basically they used materials of construction that were typically softer than what we use. We use stainless steel construction. It's hardened, and so consequently during impact, they would receive a lot of deformation on the caps, and they would see a lot of wear on the outside of the body. Being that it's 100% stainless steel, you know, we have great corrosion protection, and it's a military grade stainless steel and hardened. So that, along with the piston rod and the blending of materials, give the product a better performance and a longer life, and it allows us to provide the 10-year million round guarantee.
That's awesome. I mean, if a million rounds, okay, that to me is 50 to 60 different barrels in your AR.
Right. Right.
Doggone, that's incredible.
You
said you've taken these up to...
Yeah, we cycle test every product that we have. We have a machine, and some products have over 10 million cycles on it. We test it prior to cycle testing and intermediate points during the cycle test, and we see very, very little degradation in performance, and when we do our drop test to simulate the actual mechanism working inside the gun.
One of the other things we had failures with in the military were with heat and with cold. So
yeah.
How did you fix that?
Well, one of the things that we noticed with a lot of the competitive product is that they didn't have a consistent fill process, and there was always a little air entrapment inside the product.
So the reservoir wasn't full?
The reservoir, the complete reservoir where all the hydraulic damping happens, wasn't completely full. And by virtue of the temperature expansion and contract, it caused the bubble to expand and contract, and it creates a degradation in the damping performance because that oil mixes with that air, and then it creates, you know, a situation where the forces are inconsistent and stable as it's being stroked.
Okay, now some of the other hydraulic buffers that I've received in the past and I've tried to use, either I pulled them out of the package and they were leaking, or I put them in a gun and I started shooting and I couldn't tell that they were leaking because I had oil on the gun anyway. So how do you eliminate the leakage?
Well, we have, you know, 30 years of experience in hydraulic damping, and we used a lot of the things that we learned and the lessons learned over the years in the blending of how we manufacture our piston rods, the surface finishes, and we've actually pick premium materials for the seals because that's the most important part of the product. And we also have a thing that we do with our bearing where we support both sides of the seal so that if there is any side load that occurs, you're not loading the seal lips up.
And side load is like an uneven load.
Yeah, it's an uneven load that happens on the side of on the piston rod. That's correct.
Okay.
Yes.
Okay, so you've eliminated that.
And one other thing we've done is we've worked with one of our elastomer specialists to really change the way the damping happens on this elastomer, and a lot of the other companies were having problems with this extruding, this rubber would extrude, so we redesigned the back end of this to prevent all those issues that we're having with previous competitive products where this elastomer would degrade over time and then, you know, ultimately crack and fail and then become ineffective.
Okay, so as a shooter, there's a couple things I'm looking for. One is recoil reduction. I want to keep the sights on target longer, get them back on the target faster, and then when the bolt goes forward, that's part of that as well. So right. Explain how you're making that happen.
What happens generally is the bolt carrier comes back, impacts the buffer. As the complete system comes back, and it impacts the back of the stock, and then the spring re-expands itself and hits. As the buffer hits the detent that holds it in place, we absorb all that residual spring energy that would cause the gun to move as you're shooting. So we think that each one of those impacts and the energy we absorb in each one of those impacts actually helps stabilize the gun and keep you on target longer.
Okay, and it works with, I've shot them with a varying degrees of ammo, so I've got heavy bullets, light bullets. I can pick the buffer that I want for that specific system. My favorite, since I shoot a mid-length gas system a lot, or the one that you make for the 300 Blackout or the mid-length, I can shoot 55, 70s, and I haven't had any issues with any of them. And what I notice is, instead of the gun tracking so high into the right like it normally does, it reduces that significantly.
That's correct.
And I feel like I can get a little bit faster on the trigger.
That's correct. That's correct. And we hear that from a lot of our customers, that they can stay on target longer, and their groupings and their clustering become very tight because the gun's they don't get the muzzle rise that they have experienced with other systems and tune mass dampers.
And with your shotgun system, it makes shooting shotgun slugs, it still doesn't make it fun, but it takes a lot of the abuse out of shooting slugs or shooting the heavy loads.
That's correct.
Now, the system that you made for the shotgun requires you to do what?
Well, it's very interesting because this product in and of itself is tunable to any kind of load that you're shooting, and it also is adjustable, so that in many cases what we have found is if you were shooting, let's say number 8 shot high brass, it actually makes the shotgun feel like you're shooting a 22. When you get into some 3-inch magnums and stuff like that, it makes the gun feel like it's a low brass number 8 shot, so you're almost shooting bird shot. We're estimating at this point we're taking about 80% of that energy out in each one of those events, and it actually creates a situation where you feel a lot less recoil. In fact, my 12-year-old daughter can now shoot a 12 gauge shotgun, and she doesn't flinch at all with this product.
Speaking of the recoil, now what you've told me in the past, you said you take recoil and you turn it into heat.
That's correct.
Are these buffers ever going to get so hot you can't hang on to them?
No, there's enough mass here that allows the heat to be dissipated from a surface area point of view, and there's so much metal here that in order to heat it up to the point where you couldn't even touch it, it would never get there to that point. Okay. It basically, the surface area of itself dissipates the heat quite quickly.
Okay, Jerry, well, thanks for coming out here. It's great to learn about these KinShot products. They're made in the United States of America, which means a whole lot to a lot of us out there.
Yes, sir.
You got to try these out. Get out on the range, shoot them a little bit. They're making buffers for 9mm, 9mm carbines, for 5.56 carbines, 7.62 rifles, any of the AR type platforms, as well as the shotgun. Check them out, KinShot, and thanks again, Jerry, for coming out.
Thank you, Kyle.
All right, folks, we'll see you on the range.